Welcome guys to today's class. In today's video, we want to look into another important experiment in practical physics, and that is experiment on horizontal vibrating rule. So if this is the first time of coming across our video, yes, you will surely enjoy our video. So do well to click subscribe, click like button, comment, share to your classmates and friends so that they will learn as well with you. Okay, what is the aim of this experiment or objective of this experiment? To determine the relationship between the periodic time t and the length l of a bipolar suspension of a half-meter rule. That means at the end of this experiment, we'll be able to see the relationship between time and length, so to speak. Then the apparatus, half-meter rule, thread, two stands and clamps, and stopwatch. Let's go to the method of procedure. Suspend a half-meter rule horizontally with a graduated face up by a pair of vertical threads of length L equals to 80 cm. Each attach 5 cm from the end of the rule. Displace the ends of the rule through an angle theta and release the rule to perform angular oscillations in horizontal plane about a vertical axis through the center of the rule. Measure time for 10 oscillations. Repeat the experiment for L equal to 70 cm, 60 cm, 50 cm, 40 cm, 30 and 20 cm. So this is the apparatus setup of this experiment, where you have thread, the rotor stand, the meter rule, the angle of displacement. Yes. Now, it is important to note that this experiment, so to speak, obeys all the principles of what? Simple pendulum. In simple pendulum, we have a lot of formulas there. And one of such formulas we have is that period is equal to 2 pi root L over G. We also have period equals to 2 pi root M over K and others. Let's talk about this one especially. Do you know that we can rearrange this to get a lot of things here? Take for instance, when you write T from law of indices is equal to 2 pi root what? L all over root what? G. Do you know that what you are having here, let's package it well, root G. Do you know that this simply means T equals to 2 pi, root L means L raised to power 1 over 2, all over, then carry this root G, bring it here, root what? G. And do you also know that this means T equals to 2 pi over root G. We'll replace it with what? K raised to power 1 over 2. Where K is equals to 2 pi over root G. 2 pi over root G. Please note this concept very well. This is trying to tell you that this 1 over 2 is constant and this K is constant. Are you getting it? And so, I will use this formula now to make these my tables without performing this experiment. Yes. How do I do that? 1 over 2 is constant already and K is 2 pi over root G. Note that the value of G you will be taking should be ranging between 960 to 980. Please make use of this value, centimeter per second square. Let's write it clearly. The value of G is total to be 980 centimeter per second square. But the one you will be using in this your manipulations is to range from what? 960 to what? 980 centimeter per second square. Please don't forget this information. The reason is because if you use 960 in this, after your approximation, it can get to 980. If you use 970, after your approximation, you can get to 980. So me, I prefer I recommend students to use either 960 or 970 instead of that 980, so that after approximation everything will be falling down on 980 centimeter per second square. And so let's take 970, because I said use either 960 or 970. You will be having 2 pi all over root what? 970. So 2 pi all over root 970 should give you what? 2 shift pi divided by root 970. That will give you 0.202. That means our care is equal to 0.202. Okay? Now, this unit of your care, you know that when you have this as a constant, so to speak, now that is what you will use to do your what? Your table, or to make your table. We are saying in essence that as you have t equals to 2 pi root L all over root G, root L all over root G, we are saying that your k is equals to 2 pi over root G, and your the power of L, which is n, equals to what? 1 over 2, or 0.5. We say note this. Then we are now saying that when you check for k, unit of k should be in seconds. Unit of k should be in seconds. Yes, because after the calculations are done, it will leave you in seconds. Okay, so 1 over 2 will have no unit, so to speak. It has no unit. Then, after you have achieved this your k, the implication is that you should just come and say t equals to, instead of writing k, 0.202, which is 2 pi over root g, times what? Square root of, or times what? What is your L? 80 raised to power of what? 0.5. 0.5 means 1 over 2. That is the power. That is where we got it from square root. This square root sign. Square root L mean raised by 1 over 2. That is what we are saying. So that 1 over 2 is what we are saying, 0.5. So I will be pressing my calculator. 0.202 times 80 raised to power of 0.5. That will be giving me 1.81. I'll write it under the capital T. 1.81 approximately. Like, put it in 2 decimal place, so to speak. You do the one of 70 by cleaning this 80 and replace it with what? 70. Okay? We don't want to perform the experiment, so that is why we are doing it this way. Times 70 raised to the power of 0.5. 1.69. 1.69. Wow. Then we go again. Replace this with 60. 0.202 times 60 raised to the power of 0.5. 1.56. 1.56. We go again. We now say that we replace here with 50. Okay? We'll be having 0.202 times 60, okay, times 50 raised to the power of 0.5. 1.43. Then replace here with 40. So if you replace it with 40, you have 1.28. Replace it with 30, then you have 1.11. Then you replace it with 20. When you replace it with 20, you have 0.90. So we have gotten our period. Yes, without touching apparatus. How can we get your Tm? That is the next. Remember that your T period is equals to mean time all over what? Number of oscillation. And number of oscillation is 10. And therefore, Tm will be equals to n times capital T, where n is equals to 10. So 10 times this will be giving me 18.10, 16.90, 15.60. 10 times this, 14.30, 12.80. 10 times this, 11.10, 9.00. We have gotten the what? Mean time of the oscillation. Then T1 and T2, how can we get it? You say this your T1 is equals to Tm plus 1.00. Then T2 equals to Tm minus 1.00. Please use 1.00 so that it will be a unique number. So this minus 1 will be this plus 1 will be giving me 19.10 minus 1, 17.10. Then this one, 16.90, 15.90. This plus 1 will be giving me 17.90, and this one minus 1 will be giving 15.90. This plus 1, 16.60, minus 1, 14.60. Such that when you add and divide by 2, you get it, because this is gotten by add this to divide by 2, you get this. So this one, 15.30, then 13.30. Then this one, 13.80, then 11.80. Then add 1, 12.10, 10.10. Add 1, 10.00, and this will give me what? 8.00. So that means when you do this, add this divide by 2, add the divide by 2, you get this. Then we go to our log T table. How do we get our log T table? Get the log of 1.81. Log 1.81, 0.258, 0.258. Log 1.69, 0.228, 0.228. Log 1.56, 0.193. Log 1.43, 0.155. Log 1.28, 0.107. Log 1.11, 0.045. Log 0.90 minus 0.04, let's write it clearly. This gives minus 0.046. Then we are done with log T. What about log L? Get the log of 80, 70. Log 80, 1.90. Log 70, 1.85. 1.845. Then log 60, 1.778. Log 50, 1.699. Log 40, 1.602. Log 30, 1.477. Log 20, 1.301. 1.301. So this is just how to get your what table of values without what looking at those procedure, performing and be encountering 1001 errors. With this, you have gotten your what table of values without touching what apparatus. Let's go to the graphical aspect of this experiment. Okay, remember we said this is just with the use of formula method. You can use 960 as your G or 970 as your G for the computation to be done. And when you are done, this n is 1/2 is constant, gotten from what is the value of square root. It means 1/2, that is 0.5. So with that, we have gotten the table of value of this experiment. Let's go into the graphical aspect. So these are the questions we have to answer in this experiment. And question number 1 goes this way. Assume that T and L are related by the equation T equal to ALC, where A and C are constant. Transform the equation by taking log of both sides to obtain log T equal to C log L plus log A. I'll still show you how this transformation is done. Yes. Question 2. Plot a graph of log T against log L. Measure the slope and intercept. Measure the constant C and A. Evaluate the standard error in A and C. Number 6. What aspect of the setup is the constant A likely to depend upon? So we have to know what is the constant A. Then we'll now be able to know what aspect of the setup is likely to depend on. Then number 7, what is the unit of A? You see why we say there is need to know what is the constant A. When you know the constant A, you will know the unit of A. If the ratio as given above is valid, yes. Guess any practical application of this setup in nature. Should theta be larger or smaller, and why? Precautions, because I say at the end of every experiment, don't forget to bring in your precautions. Then the last one, our conclusion. In our conclusion, we will likely have to tell them if it is true that the period or the periodic time depends on length, and if it is not true, we'll have a lot to discuss here. Let's see how to do it. Let's go to the graph first of all. Okay, so this is the graphical aspect of this experiment. Okay, remember that question number 1 say assume that T and L are related by the equation. They say assume that T and L are related by the equation T equals to A L raised to the power of C. And now they say where A and C are constant, transform the equation by taking log of both sides to obtain T equals to C log L plus log A. That was the question. Now I want to see how to transform it so that we'll know what we are doing. In this equation, we said that this equation obeys simple pendulum equation where C theoretically is equal to 0.5 and A theoretically is equal to 0.202 seconds. That is about theoretically. I'm just giving you the expo. So that you'll be aware. And with this information, we were able to use it to do our calculation, so to speak. To transform this equation now, you take the log of both sides. Why are you taking the log? So as to bring out this power of C, so as to bring it down. And how do you do that? You say taking log of both sides, we have that log T equals to log what? A raised to power of C. Everything will be in bracket. Then applying addition law of logarithm, we'll be having that log T will be equals to log of A plus log of what? L raised to power of C. That is how you split it. And so, because there is log beside this L raised power C, this C will come down. And we'll be having that equation to go this way. Log what? T equals to, when C come down, it becomes C log what? L plus this one log A. We are just what? Transforming it. By writing this first before this, obeying the commutative law of what? Multiplication and addition. What I mean by commutative law of multiplication and addition is that in mathematics, if they tell you 2 plus 3, it is something as 3 plus 2. So log A plus log L raised power C, it's something as log L raised power C plus log A. That is what I mean by commutative law of what? Addition. Okay, remember that we said T equal to A L raised power C. We said it in the starting of the experiment when we wanted to make this table of values. And we said that it is obeying that simple pendulum equation that says T equals to 2 pi root L over G, where when you transform it to this form, we have C to be equal to 0.5 and A to be equals to 4 pi square over G. A equals to 2 pi over root G, if I'm not making mistake. We say A is equal to 2 pi all over root G. And we pick our G to be 970 cm. We'll plug it here and it's giving you 0.202 seconds. The unit is in seconds, so to speak. That is about theory. Because you understand the experiment very well, that is why you note all this. But you are noting it on your mind. You don't just write it down until you are done with your what? Experiment. I just want to let you know so that you will not forget what I said in the starting of the what? This experiment. Please note this. Yes, that is about theoretical. Then, if you want to commence the graphical aspect of a plotting of graph, then you need to know that you write the date first and write the title of the graph. A graph of what? A graph of log what? T against what? Log L. Remember, they have no unit. Then label here to be log what? T. And label here to be what? Log L. Yes. Then, before you do your graph plotting, also remember that you need to add all these values. Add this. this plus this plus this plus this plus this plus this, then minus this. Whatever it gives you, you divide it by how many they are. 1, 2, 3, 4, 5, 6, 7. Divide it by 7. You'll be getting what? 0.13 4. This plus this plus this plus this plus this plus this plus this. Divided by 7. You also get what? 1.658. This will be taken to be coordinates of the word centroid. Coordinates of the centroid. And that is what I located here. I decided to choose this scale this way because the question demands that we should get the intercept. We should get the intercept. And we need to make sure that the scale we use is such that we will be able to get the intercept clearly. Are you getting what we are saying? And so I decided to use the scale this way. What scale did I use? The scale goes this way, that scale. On the word log t axis, we have that 2 cm. 2 cm means from this 0 to this point. That this is about 1 cm, 1 cm. Each of these big balls is about 1 cm. 1 cm because they are small. They are small. So if you merge it to get the 2 cm, 2 cm represent what? 0.2 units. No units. Don't put any unit of the log. It doesn't have any units. Then for log L axis, we say 2 cm also represents what? 0.2 units. Okay, so we have that. That scale is very important. You don't forget that. Let's locate our points. This is 1.9. 1.9, this is 1.8, this is 1.9 against what? 0. This is approximately to 0.3. 0.3 is here. That is how we located this. 0.2 in one decimal place, 0.2 against 1.85. 0.2. This is 1.8. 1.85 will be in between 1.8 and 1.9. This is 0.2. Then we now say again 0.2 again. This is to one decimal, 0.2. Or look at 0.19 against 1.8. Look at 1.8 and look at that 0.19. Are you getting it? Then 0.155 against 1.7. Look at 1.7, 0.155. In between 0.1 and 0.2. Then 0.1 against what? 1.6. 0.1 against 1.6. 0.045 against what? 1.48. 1.48. 0.0 in between 0.1 and 0. You have it. Then minus 0.0046 against 1.3. In between, look at 1.2, 1.4. So 1.3 is here. And in between 0 and 0.1, you have this. Then the centroid, 0.13 against 1.66. 0.13. Look at 0.1. 0.13 is against what? 1.3. 1.6. Look at 1.65 or 1.66 is there. So we have located 1.66 against 0.3 or 0.13. Look at 0.1 in approximation pattern. Now you need to also note that this is just a sketch of graph. When you use your standard wire graph or standard graph sheet and you're able to put this scale the way we put it, do your plotting, you will be able to get your exact value, so to speak. Okay, so we now locate our line of best fit. Remember that the line of best fit, why we are getting the centroid, is to make sure that the line of best fit pass through that centroid. If the line of best fit do not pass through the centroid, that is a wrong line of best fit. So this is our line of best fit, this line. And so to get our slope now, I will get my vertical. You use your ruler to get your own, and get my horizontal. So my slope is going to be, what is change slope equals to change in log what t all over change in log what l. What is change in log t? Highest point here is 0.15. 0.15 minus minus here is minus 0.4, so 0.4. I put this minus because I know that the lower part is at the what, minus 0.4, all over this one where the vertical and horizontal intersect. Trace it. 1.7 minus what, 0.6. Are you getting it? So once you are done with that, you'll be able to get your slope. Let's use that. Minus times minus is plus. 0.15 plus 0.4 divided by bracket 1.7 minus 0.6. That is 0.5. You have your slope to be equal to 0.5. What is your intercept? Your intercept, go to your y-axis. Where does it cut your y-axis? Look at it. It's cutting your y-axis as minus 0.7. You say minus 0.7. No unit for intercept and no unit for slope, so to speak. Are you getting it? Because your intercept is located at log t axis, and log t axis does not have any unit, so to speak. So we have gotten our slope and we have gotten our intercept. Now, how do we get error in slope and error in intercept? That is another information. So this slope we got is gotten from slope of line of best fit, and this intercept is intercept from what? Line of best fit, where it meets your vertical axis. Now, how do we get the error in slope and error in intercept? To get the error in slope and error in intercept, we need to also what? Go and locate that our what? Our centroid. When we locate our centroid, those points that fell out, connect some of those points that fell out with the what? Centroid. So I'll be connecting them now. Please bear with me. Exercise patience as we do the connection. So as you can see, I've connected another line with this centroid, that is from with this point that fell out, with these 2 points that fell out. Are you getting it? And look at the centroid. Once you locate that centroid, you put it in a circle. Okay? So as I've connected them now, I will have to also note the slope of this what? Line of worst fit. Look at how it pass. Okay? I will now look. I can say, let me connect it like this. Okay. So you will be having that here, our slope is going to be, you get the vertical on, then get the what? Or is the lower part of it. So the slope of worst fit is equal to, the higher is what? Minus 0.1 minus the lower is what? Minus 0.5 all over this is what? 1.2 minus this is what? 0.2. So we also bring our calculator to compute that. You will be having that minus minus is plus. 0.5 minus 0.1 divided by this minus this will give you 1.0 divided by 1, that will be giving you 0.4. We'll have it to be 0.4. That is the slope of what? Worst fit. And what is the intercept? The intercept meets your y as about 0.06. So its intercept of worst fit is equal to minus 0.6. We note this, we know this. This is about the best fit, and this is about the worst fit. So once you're able to get the slope of the worst fit and the intercept of the worst fit, you have to tell them that in conclusion, my slope will be equal to slope plus or minus 0.5. This one of best fit minus one of worst fit. 0.5 minus 0.4. That will be giving me 0.1. No unit. It's a standard what? Error. SE. So our slope is 0.5 plus or minus. Get the difference or get what you will, the value of the one of best fit minus one of worst fit. Once you minus, it will give you negative, take the positive value of it. If it gives you positive, take the positive value of it. The answer must be what? Positive. What am I saying in essence? What I'm saying in essence is that when you are talking about error in slope is equal to modulus of what? Slope of best fit minus slope of worst fit. So when you what? Minus them. Modulus means if you get negative, forget about negative. But if you get positive, the answer should be in positive side. So the best fit is 0.5 and worst fit is 0.4. You subtract. Same with error in intercept. Error in intercept equals to intercept of best fit minus intercept of worst fit. You subtract it. Minus 0.07 minus 0.7 minus 0.6. That will be giving you minus 0.1. Minus 0.7 minus 0.7 minus 0.6. That will be giving me what? Minus 0.1. Because of this modulus, forget about the minus you have in that 0.1. So it will now be equal to what? 0.1. Forget about the negative sign, because our error in slope shouldn't be in negative. That is what it means. Therefore, it means that our intercept is minus 0.7 plus or minus 0.1 standard error, so to speak. Remember, this is our date of experiment, and this is the title, this is your scale. Okay, so we've been able to get our slope, our intercept, our error in slope, and our error in what? Intercept. Then the next question is, we should measure the constant C and A. Remember that when we were getting our slope and our intercept, they didn't tell you to get the error in slope and error in intercept. You are the one that will do it by yourself. Whenever you are getting your slope and you are getting your intercept, try to get the error in that slope and error in it and attach to it. It has its own mark. And so have it to your mind, so to speak. So To get the to answer that next question of measure the value of C and the value of what? A. So what do they mean by that statement? When we talk about log what? T equals to C log A, C log L plus log what? A. The implication is that when you compare it with y equals to what? MS plus C. M becomes your slope, that is your C. Because when you plot y against x, M will become your slope. So when you plot log t against log L, C become your slope. So M is equal to C, log A is equal to DC. Let's use a different letter. Equals to K, where K is your intercept. Okay? So how do we get a value for C? The constant C automatically is the value of your slope. The constant C automatically is the value of your slope. So C, which is your slope, is equal to 0.5 because that is what we got. Then for the error in slope, we have already gotten it. The error in slope is equal to plus or minus 0.1 standard error. You see the need why, whether they ask you or not, once they say find your slope, once you get your slope, attach the error in it without being asked. If you are fortunate that they ask you the error also, you are still on a good side. Now, what do we mean by what? Find the error in what? Find the A and error in A. Now, this intercept is log A. We say log A is equal to what is your intercept minus 0.7. Log A is minus 0.7. What will be your A? A will be shift log of what? Minus 0.7. That means A is take the anti-log of minus 0.7. An anti-log of minus 0.7 will be equal to 10 raised to power minus 0.7. And that will be equal to 0.2 approximately. 0.2. So we have been able to get our A from our what? Experiment. We have succeeded to get our A. Then, how do we get our error in A? Error in A is different from error in intercept. How do we get our error in A? Remember that we got our A by anti-log formula. That is 10 raised to power minus 0.7. 10 raised to power minus 0.7. Are you getting it? That is how we got our error, our value of A. Now, our error in A is equals to, you write 2.303, please this value is constant, times the value of your A. What is the value of your A? 0.2 times the value of your error in intercept. What is the error in intercept? Error in intercept is 0.1. 0.1. Do you get the gist? 2.303 times 0.2, which is the value of A, then times 0.1, which is the value of error in the what? Intercept. That is your error in A. 2.303 times what? 0.2 times 0.1. And that will be giving you 0.05 equals to 0.05. That means our A is equals to 0.2 plus or minus what? 0.05. Chikina, that is just it. 0.2 plus or minus 0.05. Do you get what we are saying? Plus or minus 0.05. That is just it. That is how to get your error in what? A. Since we got our A by anti-log method. Yes. Okay, so we have succeeded to get our A and the what value of error of it. In some textbook or in some research work, you may not see this 2.303, and you will see it that error in A is equal to 0.2 times 0.1. You just see it direct. So if you are going by that, it will also give you that A equals to 0.2 plus or minus 0.02. Yes. Now, this your A has unit. Why? Because where you got it from is from log T. And T is in seconds, but log T has no value. But when you are getting the value of T by anti-log now, it becomes in seconds. So your A is also in seconds. Your A is also in seconds. Please don't forget that. So all these things we got here is the same thing as you writing it in seconds. So A equals to 0.2 plus or minus 0.05 SE. Seconds. Seconds. Then you attach SE. That is standard error. That is the same thing you write here. A equal to 0.2 plus or minus 0.02 seconds. Attach what? SE. The implication of this information is that if you solve by saying error equal to 0.2 times 0.1, you are still on a good side because you do not know this. No problem. But if you also say 2.303 times 0.2 times 0.1, that is this times the error in what? Intercept. The error in intercept. That is 2 point times value of A times error in intercept. That is what we have. You have this. If you do not know about 2.303, just say 0.2 times 0.1. No, you are still on the track. So you just say 0.2 plus or minus 0.02 seconds. 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 And you attach what? Standard error by the side. So that is how to get your what? C, your A, your slope, your intercept, the error, and all have you. Okay? Okay, to answer question number 6, what aspect of the setup is the constant A likely to depend on? Wow. As we are about to answer this question, but have in your mind that we can answer a lot of questions from this experiment. One can equally be asked to deduce the acceleration due to gravity of that experiment or gotten from that experiment. Let me tell you, remember we said when we are driving the formulas that k is equals to 2 pi all over root g. We drive this, we show this while driving the formula, how we got this. It is from solving this t equals to 2 pi all over root g, then square root of L. That is 2 pi root L all over root G. There is a formula in simple pendulum that discusses this. Okay? And we said that this means T equals to 2 pi root all over root G L raised to power of what? C. Where your C is this square root sign you are seeing, which is equals to what? 1 over 2 as the power. Okay, that means that when you plot this graph, we will be saying that k is equal to 2 pi over root g, and we also said that the slope is equal to 1 over 2, that is 0.5. We discussed this before now. Okay, now since we have gotten our k to be equal to 2 pi over root g, right, we said that in that experiment our k is noted to be our A equals to 2 pi all over root g. What is your A? We got it to be 0.2 equals to 2 pi over root g. That means if I'm making root g subject of formula, I'll be having root g equals to 2 pi all over 0.2. Therefore, if I remove square root here to make g subject of formula, I'll be having if I remove square root here, I will square this to give me 4 pi squared all over, I will square this 0.2 squared. That is the value of your G. Oh yeah. Now 4 pi square all over 0.2 square. That should give you what? Use your calculator and set 4 shift pi squared divided by 0.2 squared. 986 point what? 96. That is approximately what? 987 centimeter per second squared. Yes, because we said the unit of 0.2 is in seconds. So second square, this one centimeter, 987 centimeter all over second square. That means I can deduce acceleration due to gravity from this experiment. You see the reason behind we using 970 while trying to what? Derive our table of values. We say use 970 because after approximations and everything will be done, you will be getting 980 or 980 something, which is the actual acceleration due to gravity on Earth. Yes. So we are getting a 987. You can imagine if we had used 980 straight away, you will be getting about 1000 or 990 ohm, and it is getting fast a bit depending on amount of approximation you did. So you can use this experiment to get acceleration due to gravity, so to speak. Okay, have that information in your mind. In case someone also asks you, why doesn't this graph pass through the origin? You try to tell them that why it did not pass through the origin is because of possible human and experimental error that are what encountered during the what experiment. You know, when you are performing experiment as an imperfect human being, you can make mistake, and either mistake from you or mistake from the instrument you are using, that will make everything not to work pass through the what origin, so to speak. So in case they ask you that, say that it is due to human and experimental error encountered in the experiment. That is why it did not pass through the what origin, because this is a simple pendulum what graph or experiment, so to speak. Okay, now going to that question number 1, which says we should what aspect of the setup is the constant A likely to depend on? First of all, what is A? A, as we derive, we say A is 0.2 seconds, right? That means A is talking about periodic time. This A represents periodic time because we got it from log T axis, periodic time. So A is your periodic time, and every period depends on a lot of things. One, it depends on length of the thread, because we use thread in this experiment. That thread used to hold that what meter rule, so to speak. It depends on the length of the thread. It depends on the mass of the ruler. It depends on the length of the thread, on the mass of the ruler, also on the strain constant K. Strain constant means the thread constant. In this case, thread will be our strength, because that is what we use to hold that what meter rule. I get, and it also depends on acceleration due to gravity of that planet. This can be proven from this formula 2 pi root what L over G. That means it's dependent on this, and from this equals to 2 pi root what M over K. You see that it depends on length of the thread, acceleration due to gravity, mass of the roller, and on the strain constant. And this is how they are related, and this is one of the formulas we note in the what phases. So the what aspect of the setup is the constant A likely? So constant A is likely depend on length of the thread. It also depend on acceleration due to gravity. It also depend on the mass of the ruler. It also depend on the strength constant. Strength. Let me write it. Strength what? Constant. Strength constant. Strength constant. Please don't forget that. Then another thing we need to also talk about is what is the unit of A if the relation as given above is valid. Indeed, it's valid because we can see it in Oram equation. It is a valid experiment, and so unit of A is going to be in seconds. because it's talking about time, periodic time. It is in seconds. Also note that. Guess any practical application of this setup in nature. Wow, in nature there is what we call seismometer. Seismometer. Look at this seismometer. What does this seismometer, what is an instrument? What is it used for? It is used to detect and measure seismic waves. That is what we call seismic waves. Seismic waves. So it's used to detect and measure seismic waves and earthquakes. So we use this experiment to do that, to measure seismic waves and what? Earthquakes. Another application of this in nature is that it is also used in physics education to demonstrate periodic and harmonic what? Motion. It is used in physics education to demonstrate periodic and harmonic what? Motion. Then another application of this in nature is that it is used in testing and research. It is used in testing and what? Research. Testing, testing, testing and what? Research. Those that are going into research, you want to test something, you want to research something. Let's say you want to check what is the acceleration due to gravity. You embark on the research, do your experiment and get. So it is used in testing and in research. It is used in physics education to demonstrate periodic and harmonic motion, and it is used in seismometer to detect and measure seismic waves and earthquakes. Yes, you can also use it to calculate or to be able to get your acceleration due to gravity. You are in a particular planet and you, let's say you enter Venus now, you want to get acceleration due to gravity of the Venus. Venus cannot be the same with the what? Earth. Even on the moon, it cannot be the same with the Earth's own. The one of the moon, I think, is 1/6 of the one of the Earth. And so if you are in the Venus, acceleration due to gravity there will not be equal to the one of Earth, because Venus is different planet than from Earth. Even though that Venus is Earth twin, it is not Earth, so to speak. It's just a twin. It's not Earth. So the acceleration due to gravity is likely not going to be the same, so to speak. Okay, so this experiment is used to measure or what? To determine acceleration due to gravity on any planet you are into performing this experiment. Okay, that is by the way. So we have mentioned about 4 applications in seismometer, in physics education, in testing and research, and in measurement of acceleration due to gravity. Should theta be larger or smaller? That is the next. And why? The theta is meant to be smaller. The reason is because once you are displacing that meter rule, it's a small way. If you displace it in small angle, the implication is that the rate it will be moving up and down will not be too fast. It just be moving it gradually, and before you know what happen, you will be able to get your exact time taken for that experiment. Yes, but if we displace it at a higher angle, it will be moving as fast as possible, and so you might not be able to get the exact time taken for maybe 10 oscillation, 15 oscillation, 20, as the case may be. So it should be what? Smaller, so as to minimize error that will be encountered in that experiment. As I said, if they ask you why does it not pass through the origin, you say due to human and what? Experimental error encountered. And so that is the reason. Then don't forget to include your precautions, whether you are asked or you are not asked. Include your precautions. What are the possible precautions you can put in this experiment? Remember, you measured the length of thread, 80, 70, 60. So do you still remember? So you measure it with what? Meter rule. And as you are measuring with meter rule, you should remember error due to parallels was avoided. Why measuring the length of the thread? By what? Placing my eye vertically downward on the metal rule. I repeat again, error due to parallels was avoided while taking my measurement of the thread by placing my eye vertically downward on the meter rule while taking the reading. Are you getting it? That is just that. Another precaution you should not forget is about the angular displacement we'll talk about. The angular displacement is going to be small. So angle, you try to tell them that care was taken while displacing the meter rule by ensuring that it is displayed at a very small angle so as to minimize error that will be encountered during counting and timing. Yes, care was taken while displacing the what meter rule by ensuring that it is displayed at a very small angle so as to minimize the error that will be encountered during counting and timing, during counting of number of oscillation and what timing. So you tell them the error you what avoided and how you avoided it. Yes, very important. Then which other one should we talk about? Okay, care was also taken while performing the experiment by ensuring that the windows are what locked and the doors are locked to minimize air resistance or to avoid air resistance. If you do not avoid air resistance can what have effects on the displacement, either increase it or decrease it. And so you need to shut your windows and doors to make sure that air resistance are avoided. Also, faulty equipments were also avoided by ensuring that the stopwatch and other equipment are in good state. You understand? So all these precautions, don't forget to include them while as you are done with everything. Then conclusion, what are you trying to conclude? You are trying to check the relationship between time and the length and other parameters, so to speak. You try to tell them that in this experiment we say that the periodic time is directly proportional. Periodic time, because the slope is positive, is directly proportional to what? L. Are you getting it? Is directly proportional to L. So how is it directly proportional to L? You remember that what? Directly proportional to root what? L all over root what? G. So it is directly proportional to root L, and it is also inversely proportional to what? Root G. Because the higher the time, the higher the period, the lower the what? Acceleration due to what? Gravity. And the lower the period, the higher the acceleration due to what? Gravity. I don't know if you are getting what we are saying. Yes. We noted that our care is in seconds, 0.2 seconds, right? And so as it's 0.2 seconds, you will be getting a particular G. What if we have 0.2 second as the value of K or the value of A, right? Assuming we have it to be 0.3, the first one 0.2, and 0.2 seconds gave you G to be equal to 987, right? Then 0.3 what are we going to get? You say 0.3 will be given 4 shift pi square divided by what? 0.3 squared. And that will be giving you that it is what? 43 what? 9. So 0.2 gave you a higher number, 0.3 gave you a lower number. You see why we say that periodic time is inversely proportional to what? G, so to speak. And it is directly proportional to what? The length. Please don't forget this, okay? And so that is how we call it a day in today's experiment. If you find this video helpful, please share it to all your classmates. Share it to all of them. Click subscribe. All them to subscribe to encourage me to put more experiments for you. Yes, any experiment we find difficult, we will see how to get it without touching apparatus. We'll see how to go about with the questions they ask there. Thanks once again for following us in our channel. Thank you. See you next time.